All right. Thanks for clicking on the video. This is to go over the snake challenge on Hack the Box and the reversing challenge. Essentially made this video because I was trying to figure this out and I just could not. I used some videos and some of my own experience to try to figure this out, and a lot of videos online were bad audio, bad visual, or they're very hard to understand and follow. So hopefully in this video, the audio is good. You can understand me and we can go through this problem together to understand the solution, not just to get the solution so you can, type it in and get your points, but actually understand what's going on. Disclaimer, I'm not like some crazy coder or hacker. I'm, I understand C and C sharp at a working level, and I mess with Python a little bit and Linux a little bit, but primarily, uh, I don't have a background in that. But I feel like I can explain this pretty well so you can understand it. So we'll go ahead and get started. You download the Python file and whatnot from HackTheBox. You go ahead and run it in your terminal. I'm on Kali Linux, and I run the Snake program. First thing it asks you, it generates a number and it asks you to put in a username. So you need to figure out what the username is. So let's go ahead and look at the actual code. So here's what the code looks like. All right. So just going through, there's some import data. They have a few. This defining what LR is up here kind of randomly by itself above snake. And then they're defining a bunch of words in here, for lack of a better term, right? They're saying, EF is equal to this hexadecimal. These are all hexadecimal numbers in here. If you didn't know that, these are essentially just a number of letter combinations that gets you a number or a letter. You'll see later on as we go through it. And then you go in here and you see, it's printing out the text from the actual for the game in the console. Who made it, your number is, and then it goes into some code here, which is important. We'll talk about later, and then it's defining some more terms in here. Okay, so first thing we need to do is find the username. So, logically, let's try to find out where username is here in the code. So we see enter your username happens here. And it's saying here, if username input, so username input is equal to, so that means up here, you have lock equals, something, or db equals something. That's defining what db is. Equal is saying like they essentially need to match. So if those are equal to each other, then you pass. Else, meaning if it's not this, then it prints wrong answer and it exits. So user input needs to equal slither. They need to have a handshake. So what is slither? Okay, well we see slithers here, and if we do a control find for slither, it comes up again here on line 38. So now slither is defined as equaling AA plus DB plus NN, EF, RR, all these different variables, which if you look up here, they're defined, right? So we know that AA equals this and RR equals this. So I'll go ahead and do one of these on screen so you can see it. And then I'll go ahead and make a cut, and I'll make notes in the side so we can see what these actually equal to. So the first one right here is RR, which is X6F. So if we go to a web page, and we'll go to hex to text for hexadecimal to text. So in that case, this hex number was X6F. X6F. Text to hex numbers. No, we want to do hex to text. Okay, so now we got O, right? So now we go in and we input # for note and O. Okay, so now we know that this hex number is 0, so we know, or O, and RR now equals O. And so now we got to go through and do all the other ones. So I'll go ahead and do those, and then we'll come back. All right, so welcome back. So now, now that you've defined or found out what all these hexadecimal numbers are and converted them to text, you can kind of see that these are letters. So these values are equal to a letter. So now if we just add them together in the string, we should get what slither equals. So if you go ahead and do this and you go through, you go AA, which is here, so A, and then we go DB, and DB is, I know someone's looking at it and they're yelling at me, right here, N. All right, next is NN. So we got NN, which is here, another A. And then we got EF, which is C. And then we got RR, which is O. And then we got GH, which is N. And then we got LR, which is all the way at the top, kind of hidden, D. And then we got TY, which is A again. So anaconda is what it spells out. So slither equals anaconda. And since we know that slither has to have a good handshake with user input in order to pass, user input is equal to whatever slither is equal to, so anaconda. So that should be our username. So let's go ahead and try that. So we go ahead and open up the program, we write in anaconda, and we pass. So now it's asking us for the password, which we don't know yet. So now comes on to the challenging part, the password, right? So the password and understanding not only where you get it, but how you get it is rather, I don't want to say challenging. I'm sure for some people it's easy, but you're obviously here to watch the video, so it wasn't easy for you. So I'll go through where you find the password and how it works so you can kind of understand it. So we need to find out what the password is, right? So just like username, we go ahead and find out where password is first, mentioned essentially. And we go through here and you see enter password. And then you see for pass, in pass input, and then like for in, all these, they're called loop statements in here. And it has to have a good handoff, a good shake, pass does, with this. So whatever this is going to be our password because it has to have a good handshake. They have to equal each other, whatever pass has in it. So you see pass up here. So we need to understand what character is or what chars is, right? So let's find out where chars is in this code. So the first instance of chars is up here. Chars equals essentially nothing. There's nothing here. So chars is blank, and you're kind of like, okay, well then what the heck? But if you see the next instance of chars, it's down here, and this pretty important piece of code block between lines 30 and 35. And this is where it's appended. So chars used to be undefined essentially, and now it's being redefined as keys encrypt. So whatever keys encrypt is what chars is now going to be. Now we could find that out pretty easy by just typing in print chars into the code line. And then it also comes back down here, right? Chars is again reappended here. So we could go ahead and type print chars as well. Now if we go ahead and save this, and we rerun the program, Python snake, but so you run that with the print function, and now it's printing out what chars is. So this is the password, okay? And most videos are going to show you that, but you kind of want to understand how and why this works. So that's what I'm going to kind of explain. And if you don't want to go into the details of it and you just want the answer, it's this number here. If you take this number, it's a decimal number, and you convert it to ASIC-I, you'll get the password. But we'll get to that, and I'll show you how it works. Okay, so now it's printed this out to the console for us, or the terminal, and we now know that this is the value of chars. So if we actually look at the code, right, I gotta reopen it real quick. If you look at chars, so now it print out chars for us, and we know that char is what we need in order to the password, right? But chars is not a character. It's not in the character form right now. It's in like an integer. It's in a numeric form. So we need to convert it to a character form by converting that decimal to an ASIC-I, just using like a browser converter. But I'm going to explain to you how that works, because that's kind of what I was interested in, and that's what I looked into. So when it comes down here, you know that it's pulling this char value from up here. So we'll go ahead and take out, well, we'll leave that in for now. But we'll go ahead, and we know chars is appended, so it's changed, the value is changed to equal now what keys encrypt is. So whatever keys encrypt is what chars is now. So if you look at the line above it, keys encrypt is defined by the sum of lock, and then this little caret top in Python is it's an XOR statement in Python, which I had to look up and study because it was not the most intuitive. But it's essentially saying that the XOR of lock and key will give you what keys encrypt is, right? And up here it says for key and keys encrypt equals lock XOR key. So what that means essentially is that it goes up to keys, right, which is up here, this string of code, and if you convert this hexadecimal to ASIC-I to characters, it says password exclamation exclamation. That's what the word will come out to be. It's kind of a little hint. Some of these other ones is like this is a troll, and try harder or something. They convert to different things. But what you need to understand is what is the value of lock, right? And that's something I kind of struggle with. What is the value of lock? So if you go and look, the first time you find lock is up here. You'll see lockpick equals something. So lockpick equals a random integer 0, and then this is a less than greater than sign. But essentially it's 0 to 1000. But you'll understand that lock is always 5, and people say that in the videos that I've seen, and I didn't really understand why, but I'll explain it to you. So in here, let's say that it gives us a random number, and it's 500. Okay, now if you go to the next line, lock is equal to lockpick times 2. So if lockpick was 500 by, it randomly gave us 500, and we times it by 2, this would be then 1000. So hopefully you're following still, basic math. And then now we go down to this next line where lock's mentioned, and now it says lock equals locked plus 10. So now lock we knew is 1000 up here because lock equals 1000. So now it's 1000 plus 10. So now it's 1010. All right, so now lock equals 1010, right? And then now down here, lock equals the lock value divided by 2. So now the lock value is, 1010 divided by 2, which is then going to be 505, right? And then the last time it's defined is lock equals the lock value, which is 505, minus the lock pick value. And if you look at the lock pick value originally, it was 500. So now we're going to take 500 minus 505, or 505 minus 500, and we're going to get 5. And if you did this with any number, 100, then you get 200, then you add 210, and then you divide that by 2 and you get 105, and then you come back here and subtract 100, you'll get 5. So lock is always 5, and that's very important, always 5. So lock is always 5. So we now know that lock and this key, keys for keys, to get our password to find out what chars is, lock is always going to be equal to 5. Now here's where the XOR comes into play. The XOR essentially is, it takes the binary form of that number. So now we need to know what the binary form is of 5. So we know it's 5 to the XOR, right, of whatever the key is, right? So up here in the key and keys, we need to know what X to the, at 0x70. So if we go to another, converter, you'll see that this first line in keys is 0x70. And if we convert that 0x70, we get the decimal number of 112. But that's not what the code that's printed out. That's not what the code that prints out says, right? If you remember, it says 117. So how does it get that number? That's plus 5, right? So how does it get that number? You would think, okay, well, it must add, the 5 from the lock, but that's not the case, because you'll see the other numbers are added by 3, and you'll wonder, well, what the heck's going on, right? What's happening is in here, it's using the binary number. So if we take the binary number of 112, it's going to be the 111 and then 4 zeros. So if we go 111, 1, 2, 3, 4 zeros, that's a binary code for 112. Now we need to know what the binary number is for 5. So if we go in here and type in 5 and convert it, we know the binary number for 5 is 101. So now this isn't 5 anymore, it's 101. It's a binary form of 5. So now what you do is essentially lay these two numbers over top of each other as if you were going to like divide them or add them, and you would have, 111000000, and then below it you'd have 101. And this is where the XOR function comes in. If they are different than each other, so as in 0 and 1, it equals 1. But if they're the same, it equals 0. And you'll see where this comes into play, because if you lay it over each other, obviously it's only the last 3 digits, so it's going to be 111, 0, and then we got to start adding. So now it's 1 and 0, so they're different from each other, right? So if they're different than each other, it's a 1. So then it's 1. It's the same, so it's a 0, and then it's different, so it's a 1. So we get 1110101. Now if we type that into our converter, we type in, so if we type in 117 into our converter, we get the binary number for form, and we can take and do a converter where we can convert. Let's do binary to decimal. Binary to decimal converter. All right, so now we know the binary number that we're looking for right here is 1110101. All right, and we get 117. So that is the first number. If you remember right, it's 117 in here. And then we got to get the next number, right? 100. So I'll do this one more time, and I'm not going to belabor it, but this is how it works, which is really interesting, and I felt very elated when I found it. So 5 is still the same, lock's still the same, but now we have the next number, which is 0, 0x61. So we need to know what that number is. So we go in and we convert that. We convert that so it's 0x61 convert, and we get 97, which the binary number is right here. So we go ahead and type that in. 1 1, 4 zeros and a 1. 1 1 and a 1. All right, same principles apply. You overlay this number on top of the 101, and then you check the differences. So we know that the first 1100 will be unchanged, and now we know if they're different. I always have to look, but if they're different, it's a 1. If they're the same, it's a 0. If they're the same, it's a 0. So it's different, so it's a 1. It's the same, so it's a 0, and it's the same, so it's a 0. What I mean by that is the last 3 digits of this number, 0011, overlaid 1101, it's different, same, same. So if it's different, it's a 1. If it's different, if it's the same, it's a 0 and a 0. So now you have this binary number, and we'll go ahead and put it in the calculator, and it is 1100100. And we'll convert it, and we get 100, which is what we were expecting. So a 100 in here, so let's make sure that's correct. This is what this is. So now we got 100. And if you went through and did every number individually, you would figure this out without running that print line, which is pretty cool. So now you understand how it works instead of just someone saying, "Hey, throw print line, print characters in here," and then now you know the number. Well, how does it work? Well, that's how it works, and that's how it's getting the sum for characters. And then down here, so now you know what the characters are, right? And you got all those numbers. That's great. Now how do you get the password? So now we go into here, into our table, and we can pull over an ASIC converter. Now I already did this, but as you can see in here, comparing your numbers to this, I put in 117, 100, 118, this whole string right here, and this is what comes out. This is the password. So for the flag, this is the flag with the username Anaconda in the appropriate format that it needs it for the website. So that's the flag. Now you see the other line down here, the first digits are the same up into here, and then they change. And you go, well, is that part of the flag? Because a lot of people get confused with that when I watch your videos. And if you read the code, you can understand why that's not the case. Down here, you'll see that it appends characters for keys encrypt. And then down here, it does the same thing. It reappends chars for chains encrypt. So chains encrypt equals the chain, which is up here, right? For chains, chain and chains. So you have chains, and you have this, this is a troll. If you spell this out in ASIC, so it's that first number, whatever it is, as a decimal plus what this is as a decimal, and it gives you that other string of characters. But if you look down in the password, it's not asking you for that. It's asking you for the characters for character from the passes, which we know the password is in keys. So it's kind of like they're salting the password with that other string in there. But so at the end, we'll go ahead and try it. Let's go ahead and close this out. Enter username Anaconda, and then the password, which we have over here on my other screen that I showed you. So we're going to go ahead and type it in. UDVVRJWA Money sign, money sign. Good job. There we go. So the password was correct. So you know the username and password are good. You just go ahead and put that in the hack the box and you've completed the flag. If you have any questions, hopefully this was good. Hopefully the cuts aren't too bad. There's some times where I pulled some things up that are some bleed over some other projects, but hopefully this made sense. This not only gave you the number or the answer for the flag, but it actually you hopefully you could understand where the username's coming from, not only where the password's coming from, but how the code works. It's all there in the code. You just got to be able to read it. And like I said, I'm not some Python guru. I know some basic coding, but you know, just get in there and Google like the carrot top, the XOR statement. Knew nothing about it, but I knew that it had something to do with the password. So I just tried to figure out how it worked. Looked up some videos on it, and found out how that operation works. And then it helped me figure out how these numbers were generated, because I saw other videos where they just did print characters and then just print it out, and they're like, all right, convert this to letters, and you got the password. Well, how are these letters? How are these numbers generated? You know what I mean? So hopefully this video helped you understand that. Um, yeah, thanks for stopping by, and hopefully this helps you figure out this hack the box. And have a nice day.